Whether within a data center or between facilities on campus or across a metro regional network, you and I know that the network is under tremendous pressure because of the AI boom. The practice of flattening the IP and optical networks, well, that's nothing new. It's been done with pluggable transceivers for quite some time. Multi-vendor 400ZR is in the market. The wave of 800ZR is rising, and we see new technologies that are going to push us to 1.6T and beyond. That's what makes this conversation with Cisco's Bill Gartner so interesting. If you want to hear about what's coming next, stay with us till the end. Welcome, Bill.
Thanks, Jim. Thanks for having me.
So first, let's talk about the transition to routed optical networking. Why does moving to a transponder-based optical system, from a transponder-based optical system to a router integrated coherent optics matter right now for service providers? What's the ROI? What's the real benefit to them?
Yeah. So, first of all, I would say we have nothing against transponders. We continue to sell transponders, and there are applications where transponders are the best fit. That would include things like ultra long haul and subsea applications for sure today. But increasingly, we believe that pluggable coherent optics are the right answer for our customers, whether it's a data center interconnect or a metro application, and now even long haul applications. And the reason is that it is just really economically compelling. If you think about a transponder sitting in an optical chassis, that optical chassis takes power and space, and it has to be managed as part of an overall optical system that includes the line system itself. But when you replace that transponder with a pluggable optic, what we have typically seen is anywhere from 50 to 60+% CapEx savings, 60+% space savings, and 90% power savings. So the economics are super compelling here. And we are constantly in a mode of trying to drive CapEx and OpEx out for our customers because they have to continue to expand capacity and they can't do it linearly. They can't expand capacity and expand their OpEx at the same rate. So we have to find ways to help them expand capacity, but do it at a much lower cost of deployment. That's both CapEx and OpEx.
Yeah, a very strong business case, right? So let's move on to AI and optics at scale. So, of course, there's the massive AI infrastructure spending that's going on right now and the expectation that that's driving 800G. But you also have 400G ultra long haul and the QDD-OLS routed optical networking driving changes in the metro and the long haul. So, tell us about all of these changes and how that is transformed by the AI infrastructure.
Yeah, let me divert a little bit, Jim, and then I'll answer your question directly. One of the things that we have learned through our customers who are doing significant training, AI training models, is that the reliability of the optics that are inside the training model, inside the back end and front end part of the AI infrastructure. So these are typically the short reach optics at 400 gig or 800 gig. The reliability of those is much, much more important in that infrastructure than it has been in a classic network application. In a classic network application, if the optic has a problem that causes a link flap, for instance, typically TCP/IP will bridge that. So your Gmail is never going to be disrupted because of a burst on the line. And even this video that we're having would probably not be impacted by a burst on the line. But in an AI application, that link flap can result in the workload stopping and having to back up and restart from a checkpoint. And that means wasted capacity of the most expensive resource in that AI infrastructure, which is the GPU. So you've got these GPUs that need to be highly utilized that are now effectively idled while the workload is backing up, restarting, and then running again in hopes that a link flap doesn't reoccur. So one of the things that we have focused a lot on is making sure that we are doing everything possible to deliver the inside the data center optics that are super high reliability for our customers that are deploying AI applications, whether it's training or inference. So that's inside the data center.
Yeah,
Now, to the question
inside a single data center, right?
inside a single
Not
data center.
right.
Now, to the question you asked, for what we are seeing mostly in the hyperscalers, but we anticipate seeing this in large enterprises as well, is sometimes that AI workload actually expands beyond a data center. And then you need data center interconnect. And it needs to be cost effective because there's massive amounts of capacity that are moving between these data centers. And I can say virtually all of the hyperscalers are deploying the coherent technology now in pluggable form. And in part because economics are super compelling, the operations are simpler because you're just plugging an optic into a router, but it's also open standard, unlike transponders. So it conforms to an open standard, which allows for multi-vendor applications and interop, which most of our customers are very happy to have multi-vendor for supply chain diversity, as well as just negotiating leverage that they obtain. Most of our customers are deploying 400 gig ZR and ZR Plus today, which ZR Plus can go about 1,000 kilometers. ZR is typically about 100 kilometers. We have some of the hyperscalers now moving to 800 gig pluggable optics. Some are going to be waiting to see 1.6T. And as you mentioned, we also introduced a 400 gig ultra long haul optic that can be used up to several thousand kilometers. And while I don't think subsea is the primary application for this, we have actually trialed the pluggable optic in subsea applications. In one case, publicly with AARNet, that was a research and education network in Australia, over 4,000 kilometers using a pluggable optic. So the pluggable optics are going to expand into more greater application spaces than simply DCI and metro as this technology matures.
Is the 800 gig scaling like you would expect?
Yes, the 800 gig is
Mhm.
the capacity for our 800 gig is growing significantly right now.
It seems one of the big stories of 2025, huh?
Yes.
So let's go back to an earlier point that you talked about, which was the CapEx savings, and I think a lot of that is perhaps tied into automation and optimization. Cisco has the routed optical networking 4.0. So tell us about that. What is the advantages that teams are seeing with this new level of automation?
Yeah. So, I mean, one of the challenges of pluggable optics is that we're bridging two domains, the IP domain and the optical domain. Historically, the optical domain was managed by an element management system or a domain controller targeted at the optical domain, and then the IP domain would have its own. And that's really the model that is deployed in most customers today. The question is, what happens when you take effectively the transponder function and now move it to the router? Because now you've got an optical function in the IP world, and there's a couple of things that are happening that help resolve that issue. One is the standards are maturing for the API that is associated with that optic, so that there are many different management systems and many different approaches for how you manage that optic, all in a very standard way, which helps simplify the world for our customers. And then secondly, Cisco acquired a company called Sedona, which developed a product that is a hierarchical controller that bridges the IP and optical domains and really helps resolve this issue of what happens between the IP and optical domain. And can we look at every layer of the stack from the services layer all the way down to the fiber and do that from a single pane of glass? And so that's what we're offering as part of our routed optical networking 4.0.
Okay. How does this end up translating to, the humans, the teams that actually end up running these networks?
Yeah, I think it's a big challenge. Organizations tend to form around architectures, and that's why you have like an IP team and an optical team. It's why you had a voice team way back in the day or TDM team. And I think we and our customers have to recognize that when you have architectural shifts, they can deliver massive benefits, really disruptive benefits, but they often require organizational shifts, and they require us to think about the organization behind that as well. And that means that there may have to be some skill transfer between domains, or there may have to be some uplifting within a domain of, the optical folks learning a little bit about IP or IP folks learning a little bit about optical. And if you're not thinking about that day one, it really can become the impediment. The technology is kind of easy. We can solve the technology problems. It's the human issues that we often face as challenges in deploying new architectures.
Yeah, talking about, what's new in terms of architecture and technology, I'd love to hear from you, Bill. What do you see as what's next? Um,
Well,
co-
I think certainly we're going to see continued growth and expansion in the pluggable coherent domain from 400 gig to 800 gig, and now coming 1.6T will be around the corner. But I think we're also looking at areas where we can deploy pluggable technology in much the same way we did with coherent, but in other applications. So we have a pluggable optical line system where customers that are looking for a very basic, very simple point to point line system can deploy it in the form of a pluggable rather than a standalone chassis. We have a pluggable PON OLT, and we call that routed PON. And instead of using a OLT chassis, standalone chassis that consumes space and power, a customer can now deploy an OLT in the form of a pluggable optic. And so I think pluggables are ripe for adopting technology that's typically been deployed in chassis-based solutions, and we're going to be doing more of that over time.
in terms of other emerging technologies like, CPO or, pushing the per lane rates up to even 448 gig, are these interesting yet from a
Cer-
commercial point of view or just in the lab?
Certainly, Cisco has invested a lot in silicon technology, and it really forms the basis for our 8000 series of routers, which is all based on Silicon One. We've deployed that technology in data center applications, in AI applications, and in service provider applications. And increasingly, that will be deployed in enterprise data center applications as well. And of course, you have to continue evolving that technology from 100 gig SerDes to 200 gig SerDes, ultimately to 400 gig. And CPO will be part of that future for us as well as customers find a need for CPO. I think there's a distinct set of criteria for where CPO would fit. It's not everywhere in the network, but I think there are certain places in the network it will fit, and we will have a CPO solution for customers when they're ready to adopt that as well.
All right, lots cooking. Thanks for the updates, Bill. We really
Thanks,
appreciate it.
Jim. Pleasure as usual. Thank you.